Okay, this is day 2 of our finding limits algebraically. Okay, so once again here our first example, we have a square root of a function minus a square root of a function. Okay, and this is going to be a pretty recognizable formula in the future. But for now, it just looks like some crazy random formula. So of course, if we're trying to figure out what this limit is, the first thing we try is direct substitution. Okay, so we plug a 0 into both h's, and you get a 0 on the bottom, and you get square root of 3x minus square root of 3x, which is 0 on the top, which means we have to do some sort of algebraic manipulation so that when we direct substitute, you no longer have zeros. Right? That's the whole entire point of doing this algebraic manipulation, is so that when you use direct substitution and you plug in your limit, you don't have zeros anymore. Okay, so with square roots, the strategy was to multiply by the conjugate. Okay, and all we do is we change this sign when you multiply by the conjugate. So we're going to multiply top and bottom by square root of 3x plus h plus the square root of 3x divided by that same thing. Okay, all we're changing is the minus sign in your original numerator to be a plus sign. So let's do some distribution in our numerator. We're going to take our first term of square root with the plus h, and we're going to multiply it by the first term. Okay, and anytime you multiply a radical by itself, those radicals cancel out, right? So we still just have the argument, what's underneath the radical. Okay, so formally we would still write the limit as h approaches 0 of, this becomes 3 times x plus h, right? The radical goes away, and we're left with the radicand. Okay, and then here's the magic. This is why you multiply by the conjugate, because this is a positive root 3x times another root, right? A positive one. And then when we come back and we do this distribution, when you multiply it by negative root 3x, okay, that's a negative of the same thing. So these two terms cancel each other out, right? The root 3x times root 3x plus h cancels out with a minus root 3x, right? Those subtract to give you 0. So then we do the negative root 3x times a positive root 3x, which turns out to be a negative 3x. Okay, so this sign, if one is a minus and one is a plus, then that is always going to be a minus in your numerator. Okay, so the reason why we multiply by the conjugate is because that gets rid of our square roots in the numerator. Okay, and we're left with just this pretty nice looking function. And on the bottom, though, we have this crazy, right, everything that we have, 3x plus h plus root 3x, right? Our denominator got really complicated, but your numerator is much simpler. Okay, and there's a reason for that, because these things are designed so that they will cancel out a little bit. So when we distribute, this becomes 3x plus 3h. And then we have our minus 3x still. Okay? So when you distribute your 3x and your 3h, the 3x's cancel out. 3x minus 3x is 0, and we just have a 3h on top. Okay? Which is also special because the h from your numerator can divide with the h in your denominator. Right? All of these things should happen if you are doing the correct sign, distribution, and other things. These problems are designed so that they can simplify nicely. Bless you. So if you're doing the problem and you're figuring that we have a whole lot of things left over, then go back and look at your minuses and your pluses. Because chances are, if things aren't canceling out, then you have a minus where there should be a plus, or a plus where there should be a minus. Right? Just go back and check your math. So this is our simplified expression. We have just a 3 on top. Everything else canceled out. The h divided by the h and the 3x's subtracted each other. So we just have a 3 in the numerator. And then the denominator, we have the square roots plus another square root. Okay. So now when we try direct substitution, when we plug in a 0 for h, okay, we have a 3 in the numerator, and we have root 3x plus root 3x. Right? No longer do we have an h at all, because the h is 0. So x plus 0, well, that's just x. So the square root of 3x plus the square root of 3x is how many square roots of 3x? 2 of them. So our final answer is 3 over 2 square root of 3x. Okay, so something to be aware of, if we look back at the beginning, notice that we have an x and an h in your original equation, and we're looking for the limit as h goes to 0. So if we have an x and an h, 2 letters, that means your answer is going to be some type of an equation, right? It will have an h in it at the end. So that's something to be aware of as you're working through these problems. Okay, our next example, this is a polynomial one, so you should be thinking about factoring. Anytime we have a polynomial, we should be thinking about factoring. So here are your cubic factoring rules. So if you have a cubed plus b cubed, that factors to this, a squared plus ab. Nope, it's a minus ab, sorry. There's a minus in here. Plus b squared. Okay, and if there's a minus, then it's a minus b as your factor, and then both of these are pluses. Okay, so those are your cubic formulas for cubic factoring. Okay, because we want to factor anytime we have polynomials. Okay, so let's write x cubed minus 27 in this form. So what number cubed is 27? And that would be 3. 3 times 3 times 3 is 27. So in your formula, a is going to be x, and b is going to be 3. Okay, so we're using this formula. We're applying this cubic factoring formula. So x minus 3 is the first part of your cubic factorization. And then we have x squared plus x times 3, which is 3x. And then 3 squared is 9. Okay, so that's the factorization of x cubed minus 27. And then, of course, we still have an x minus 3 in your denominator. So look what divides out. X minus 3 and x minus 3. Okay, which is fantastic, because now we can use direct substitution. We can plug 3 into both of our x's, and we get 3 squared, which is 9, plus 3 times 3, which is 9, plus 9 means we have a limit of 27. Okay, let's look at our, what is this example? Okay, this one is probably not as tricky as you might think. Yes, it has this new symbol here, this delta x. Okay, which if you've got any physics previous experience, you should know delta x means change in x. Okay, when we get to doing integrals, delta x will be in there for integrals. But if we try direct substitution, that becomes a 0 and that becomes a 0. 3x minus 3x is 0, so direct substitution straight away is not a good thing to do. So let's just distribute. Let's just try and simplify this straight away. Okay, so 3x plus 3 delta x, right, which is just another variable like a y or a z or a q, minus 3x. So if we distribute, what do we see subtracts? The 3x and the 3x. Okay, and just like our example above, we have 3 delta x over delta x. So what can we divide out? the delta x divides to give you 1, right? Because it's multiplication. 3 times delta x divided by delta x is just 3. Right? So no longer do we have any variables at all. Our answer is just 3. So what looked like it was pretty tricky turned out to be a pretty simple problem. Okay, this one's going to require us to do some work here and some understanding. So we have f of x plus delta x, right? So we have a sum in parentheses minus f of x. Okay, and it's telling us that this is our function that f of x is representing. So everywhere we see an f, we're going to put 2x minus 5. Okay, and here we're going to replace our x value with x plus delta x. Okay, so the first thing to do is understand that this is a functional notation, and where this is our function that we're trying to evaluate. Okay, so let me rewrite this and see if we can make sense of it. So we have the limit as delta x goes to 0 of. So our function was 2x plus 5. So it says replace x in your function with x plus delta x. That's what this is telling us to do. In your equation, replace the x value with x plus delta x. Okay, so this is our first step, replacing x in our function with this sum. Okay, minus, it says now subtract off the original function. So we're going to subtract 2x minus 5. That's your original function. Okay, so very similar to what we saw up above in that previous example. Right? Notice right here we have 3 times x plus delta x. Well, that's the same as if our x value were replaced. Okay, so this is a special form called the difference quotient, which we're going to learn when we talk about derivatives. But this is what we're looking for. Okay, we're going to start here and then do as much simplifying as possible. Okay, so this simplifying step is let's just distribute and get everything out of parentheses. Okay, so let's simplify by getting everything out of parentheses. So this is a 2x plus 2 delta x minus 5. Okay, that's that first part of our equation. 2x plus 2 delta x minus 5. And then minus 2x, and then minus a minus is a plus 5. So we minus the 2x, and then we minus the minus 5. And we're dividing that all by delta x. Okay, so let's simplify some more. What do you notice when we simplify this numerator? The 2x and the 2x subtract each other out. The 5s and the minus 5 subtract each other out. And the delta x divided by delta x. Okay, these problems are designed to do this. Okay, they're designed to simplify like this. So what's our only thing that's left? 2. So even though, right, this looks like a very complicated formula, the answer to this is actually pretty simple. Okay, so we're going to learn that this is called the difference quotient. Okay, that's called the difference quotient, and it's going to help us with our definition of a derivative in the future. Okay, so there's one more thing that I want to talk about before we let you go today, and that's something called the squeeze theorem. Okay, the squeeze theorem. So the squeeze theorem basically says if we know the limit of some function, okay, so we're going to talk about the limit as x approaches 0 of some function. Okay, if we know that this exists, and let's just say that it's this number right there, right? So the 0 can change, right? It doesn't really matter what number is here. But let's say that we have a graph called f, and we know that it has a limit at 0. Okay, we don't know what the limit is, right? It doesn't really matter. They say that they use the letter L for limit, capital L for limit. Okay, so there's a function f that has a limit at 0. Okay, and there's another function, g, that also has a limit at the same place. And that should have gone through that value there. Okay, so both our f and our g have the same limit at 0. Okay, is this understandable that there are two functions that do this? Okay, so imagine, if you will, right, use your amazing imagination, that there's some third function. We'll call this third function h. And we know that all the values of h are less than f and greater than g. Okay, so this function h is somewhere in between your white line and your yellow line everywhere. Okay, so this says that the limit as x approaches 0 of h. What do you think that value is going to be? If h is always between g and l, what is going to be the limit? It's going to be the same. So whatever this limit is here, because h is between f and g, right, and those both go to l here, right, maybe it's 4, that means that h also has to go to 4. Okay, so we can know by the squeeze theorem that if there's two functions that we know the limits of, and there's a third function that we might not be sure of, but we know how it relates to the other two, then by the squeeze theorem, that function has to have the same limit as the other two, right? At a certain value, right? So they're all going to 0. At 7, that might not be true. At -2, that might not be true. But at 0, that's going to be true. Okay, so there's a couple problems on your homework that are asking about the squeeze theorem. This is how you know that we're using the squeeze theorem, that there's some random function in between two functions that we know. Okay, so you're going to need to know that for your homework. So when we're trying to find a limit, you want to do your best to simplify as much as we can so that direct substitution gives you an actual answer and not a 0 over 0.